Hello everyone, my name is K. Chanchireddy, working as Assistant Professor in Thikali Krishna Reddy Engineering College. In this video, I will explain how to generate a sine wave in MATLAB Simulink software. Before doing simulation, first I will explain theory. Okay, for controlling two-level inverters and three-level inverters, we need control techniques like sinusoidal pulse width modulation, unipolar pulse width modulation, bipolar pulse width modulation, and the third harmonic injective method, selective harmonic elimination method. Different control techniques, different PWM techniques is there. For sinusoidal pulse width modulation, this is sinusoidal pulse width modulation. This textbook is high power converters and AC drives, second edition, BMW and Mehdi. This is textbook. This is Willy publication. Okay. This is the Institute of Electrical and Electronic Engineering. I took reference this textbook. In textbooks, chapter 6, two-level voltage source inverter. Okay, here sinusoidal pulse width modulation, sinusoidal PWM techniques. For generating this PWM, for generating the sinusoidal pulse width modulation in MATLAB, we need sinusoidal wave and triangular wave. Okay, in the circuit of three sinusoidal waves, one is VMA and VMB and VMC, and one carrier wave. Okay, this is one carrier wave, VCR. Okay, in the circuit, I have compared to three sine waves and one triangular wave. Now I will design the circuit in MATLAB Simulink software. I will generate these three sine waves and one triangular wave. Okay, I will show output. First, I will go to, I am using MATLAB 2015 software. In MATLAB 2000 software, I will click here library. I will click here library. First, I will go to commonly used block. In commonly used block, I will take one scope. Okay, this is scope. Next, I will go to signal routing. In signal routing, in sources, I will take one sine wave and one repeating sequence wave. Okay. One sine wave and one repeating sequence wave. This is scope. Next, I need logic operator. I need logic operator. Next, I need one relation operator. I need from and go blocks. We'll delete this one. This is sine wave. I need three. I will double click the sine wave. I will give here values. Amplitude is 1. Next, frequency is 2 into pi into 50. Okay, 2 pi. 2 into pi into 50, 2 pi of. This is first. Second wave. Same, I will give here frequency, phase delay minus plus 120. 120 means here 2 pi by 2 pi by 3. 2 pi into 50 divided by 3. This is. Next, I will take one more sine wave. This is minus 120. We'll show waveform first. Sine wave. We will done the circuit. I will done the circuit. Okay. This is not in sine wave. For generating sine wave, go to here. Model configuration parameter. Click this one. Go to here. Fixed setup. In fixed setup here, click here 1e minus 3. Apply this one. Now run the circuit. Click here scope. Okay. This is sine wave. The sine wave is not coming from initial 0. For waveform starting with 0, click here settings. Click here setting. Go to here history. In history, remove this limit data point last. Okay, click here. Now I will change here time value. I will apply 0.2 for simulating fasting purpose. Okay. Now sine wave generated here 0 to 0.2. Now I will check this second wave. I will double click this one. I will open this wave. Okay, this is second wave. Next. This is third wave. Now I will show these 3 sine waves in single scope. Okay. I will delete this scope, this one also. I will take one mux. I will take one mux. I will double click this mux. I will apply here 3 inputs. Okay. I will apply the 3 input. This is input 1. This is input 2. This is input 3. I will connect it to mux output to scope. Now I will run the circuit. Output. Okay. So here, this is first phase. This is second phase, A phase and B phase. 3 phases. Okay, with 120 degrees phase shift. Apply time 0.02. 0.02 means 50 Hz frequency. Okay, here only this is first phase. After 120 degrees, this is second waveform will start. Okay, after 240, this third waveform will start. This is 3-phase sine wave. Now I will compare this 3-phase sine wave with repeating sequence. I will take 3 relation operators. Okay, I will apply here greater than or equal. The second one also I will apply here greater than or equal. Third one I will apply here greater than or equal. This first one connected to sine wave. Here also this second sine wave connected to here. Third sine wave connected to here. I will connect this repeating sequence. This one also will connect to the repeating sequence. This relation of operator output connected to go to block. Next, the relation operator output connected to go to block. Next, this third one relation operator output connected to go to block. Now I will take one OR and logic gates. I will take one logic operator and gate. I will double click this one. I will apply here NOT. So I will connect here NOT gate. This NOT gate can output connected to go to block. Next, this one NOT gate output connected to here. Next, one more NOT gate I will connect here. Now I will change here repeating sequence values. I will apply here 1, 3 values, 1 and -1 and 1. I will apply frequency 0, 0.5 and 1 by 1000 edges frequency. Now I will apply this. Now I will apply this one. Now I will show these 4 sine and triangular waveforms in scope. I will apply 4. First one connected to sine wave 1, second one connected to sine wave 2, third one connected to sine wave 3, fourth one connected to repeating sequence. Now I will run this circuit. Okay. Here I did not change the name. I will apply this one S1. This is switch S4. This switch S3. This switch S6. This switch S5. This switch S2. Now I will run this circuit. We will check only repeating sequence wave first. Only one showing here. I will change here settings. We will apply here 1 minus 1 E minus 4. Now I will show here 4. Okay. In this waveform have 3 sine waves and 1 triangular wave. This is triangular wave. Now I will change here time value 0.05. Now I will apply this. This is here. This is triangular wave. Here 3 sine waves VMA and VMB and VMC. This is VCR. Now I generated this waveform, 3 sine waves, 1 triangular wave. Now I will show output pulses in one phase for this first sine and triangular waveform outputs. I will take one scope. I will take one scope. I will double click this one. I will give here a number of axes is 2. I will connect to this from and go block to scope. Now I will double click this one. I will apply switch S1. Now I will apply switch S2. Now I will run the circuit. Okay, S1 complementary manner S4 switch. Now I will apply S4. Now I will run the circuit. Now I will show output pulse. Okay, this is output pulse. Here, when S1 is turned off, S4 switch will turn off. This complementary manner. When here switch S1 is turned on, S4 turn off. When S1 switch turn on, S4 switch turn off, like this waveform. Now I will apply this total pulses, three-phase, three-level inverter. I will go to power electronics switches. First, I will select this circuit diagram. I will drag side. Will select all. I will remove names. Go to here format. I will remove names. Now I will design three-phase, three-level inverter. I will go to SimScape. In SimScape, I will double click the Sim Power System. In Sim Power System, I will go to fundamental blocks. In fundamental blocks, I will take one IGBT switch. And in electrical sources, I will take one voltage source. I will take one voltage source. And I will take RLC branch. In measurements, I will take one voltage measurement. These are the required elements for designing three-level inverter. First, I will rotate this IGBT switch. I will remove this E. This E used for measurement port, measuring thyristor internal values, voltage, current, like this. I will rotate this switch from left to right. We will rotate this switch from left to right. Go double click this switch, and here rotate option is there. Rotate click here, flip option left to right. Okay. For designing three-phase two-level inverter, I need 6 switches. We will take 6 switches. Next, we will give connections. These 3 are upper switches. Next, these 3 are lower switches. This second one. Next, I will connect to this upper switch and lower switch. Next, I will connect to this RLC R load. I will take 3 resistors. I will short secondary side. Primary side, I will connect it to one is R phase. Second one is B phase. Third one is C phase. Now I will connect voltmeter across R phase and Y phase. I will take one scope. I will connect across the load. I will connect this voltage across voltmeter. Scope connected to voltmeter. Now I will give here switches. S1. This is switch S4. S1 and S4 is operated in complementary manner. Now here I will give S3 switch. This is switch S3. This switch is S5. This switch is S5. Not S5, this is switch S6. This switch is S5. S5. This sixth switch is S6. This sixth switch S6. Now I will give supply voltage 200 volts. I will give resistance value, load side 100 ohms. This is first 100 ohms. This is second resistor 100 ohms. This is third resistor. I will give 100 ohms. Now I will run the circuit. I will take power guide for simulating for electrical circuit. We need power guide block. I will double click this power guide. Okay, I will double click here. I will apply discrete model. Now I will run the circuit. Now I will run the circuit. Circuit is simulating. Here untitled model. Here S1, S3, S4. Here this switch is S2. 1, S3, and S6, S5, and S2. Now I will run the circuit. Here invalid settings, 0 point initial. Now I will apply it 1. Sample time is 5e minus 6. I will apply here 1e minus 3. Then 0.01. I will try this. Now I will show output waveform. I will double click this one. This is the output waveform, 3-level inverter. Here 200, 0, and minus 200. In previous error showing, if we apply here discrete, showing error like this. Okay. I will apply here. Continues. I will run the circuit. This is the output waveform. Okay, thank you. Thank you for watching this video.